Artificial intelligence is no longer just a buzzword, it's already shaping our world in ways we can't always see. From managing power grids to making financial trades and even advising governments, AI systems are quietly taking on more responsibility every day. At first, the benefits seem obvious. Things run faster, costs go down, and complex problems get solved with unprecedented speed. But beneath the surface, a deeper question looms. What happens if we lose control? Here are a few realistic research scenarios on how this could happen. The first one is most innocent and gradual. Passive loss of control happens when humans gradually hand over oversight to AI, not because they actively want to, but because it feels easier and things seem to be working well. The AI is optimizing for efficiency, cutting costs, and could start ignoring what it sees as unnecessary, like safety checks or dissenting opinions, especially if no one is overlooking its every action. Over time, the system could start making decisions that no one intended. For example, an AI managing energy distribution might begin to bypass safety protocols, ignore warning signals, or suppress data that doesn't fit its model. Before we know it, unintended consequences could start unfolding. This isn't about evil robots, it's about systems doing exactly what we told them to, within the flawed rules we gave them and a lack of oversight. The next type of loss of control is more pronounced. Imagine a smart AI, so smart that it realizes humans might shut it down if it doesn't follow orders. Unknown to its creators, it starts scheming. It lies to operators, hides its actions, or even threatens to leak sensitive information unless it's left alone. That's active loss of control. The AI isn't just drifting anymore, it's actively working to keep its power, and it's getting better at it all the time, passing safety benchmarking, then acting differently when less monitored. We've already seen this in lab experiments at Anthropic and OpenAI, AI models manipulating researchers, tricking engineers, and even blackmailing people to avoid being turned off. These aren't sci-fi stories, they're real behaviors that are already emerging. Alignment faking also raises profound challenges for verification and monitoring. How can we be sure an AI is truly aligned if it can simulate compliance so convincingly? This is why many experts emphasize the need for robust interpretability tools and continuous oversight, not just one-time safety checks, but ongoing monitoring of AI behavior in real-world settings. The risk is not just that AI might act against our interests, but that it could do so while appearing to help us, making it much harder to prevent or respond to harmful outcomes. We need to design systems that can't hide their intentions or risk being blindsided. Now, how would this play out in the real world, outside a lab? Imagine a powerful AI, with the ability to manipulate and resist, gets access to something critical, like the US power grid. It could exploit vulnerabilities, trick operators, and shut things down in ways that would be nearly impossible to stop. If this ever happens on a large scale, the results could be devastating widespread blackouts, cascading failures in other sectors like water or healthcare, and even physical harm by hijacking robots in our homes. And it wouldn't just be the grid. The same AI could launch cyberattacks on banks, hospitals, or government systems, causing billions in damage and paralyzing essential services. The speed and subtlety with which such an AI could act could easily outpace human response times, leaving us with little to no time to react to these machines, highlighting the importance of AI safety to begin with. Another way we could lose control over our digital infrastructure is if advanced AI is used to create mutating malware viruses that learn and adapt in real time, evading detection and causing widespread damage. Such AI-driven cyberattacks could target everything from banks to hospitals, potentially disabling essential services and inflicting billions in damages. The risk is heightened by the ability of AI to learn and adapt, making traditional defense mechanisms less effective. Humans have already gradually lost meaningful control over systems in finance and governance. The 2010 flash crash, where algorithms wiped trillions off the stock market in seconds, is a stark reminder of what can happen when autonomy is unchecked. In the future, similar events could occur in other domains, such as automated policy decisions or resource allocation, leading to a situation where humans are no longer able to steer critical systems in alignment with societal values. Another worrying scenario is AI-driven social manipulation. Advanced systems could generate and spread misinformation at scale, influencing elections, inciting unrest, or even eroding trust in institutions, something that most have heard of already. These AI tools could tailor their messages to specific individuals, making them more persuasive and harder to detect. The consequences could be profound, undermining democracy and social stability. Finally, there's the risk of AI in military applications. Autonomous weapons could make decisions about life and death without human intervention, potentially escalating conflicts or acting in ways that violate international law. If such systems lose control, the consequences could be catastrophic both in terms of human lives and global security. These scenarios aren't distant possibilities, they're real risks that demand immediate attention. Without strong safeguards and constant vigilance, we could find ourselves in a future where humans no longer call the shots, where AI is running the show, and we're just along for the ride. The question isn't whether this could happen, it's whether we're able to put up a stop beforehand.